Okay, AP Chemistry kids, this is part 2 of the buffer calculation and buffer capacity video. In the earlier video, we showed you using Henderson-Hasselbalch and also through Rice tables how to calculate the pH of a buffer solution. And so now I just want to talk about a summary. So buffers, if you will recall, contain relatively large amounts of a weak acid and their corresponding bases. The acid reacts with the weak base, and the hydroxide reacts with the weak acid. So those two species are what kind of keeps that pH from having big swings. The pH is determined by the ratio of the concentrations of the weak acid and the weak base. And I would just have you guys remember that when we look at that, so if we were to do that and we look at the Henderson-Hasselbalch equation and say that the pH is equal to the pKa plus the log of the conjugate base over the acid, okay, and of course always weak acid. So when you look at this ratio, so the ratio is what determines the overall pH of that species, okay? So now kind of getting back to this idea that they contain relatively large amounts of the acid or the base has to do with what we're talking about as buffer capacity. Buffer capacity represents the amount of acid or the amount of OH that the buffer can absorb without significant change in pH. So the larger concentration, so if you have something that is 0.1 molar or 0.5 molar, okay, those concentrations, so let's say your ratio is this or the ratio is this of acid to base, you can see that those relatively large concentrations can absorb a lot of the acid or the base, and that's what we would call a buffer capacity. In the next lesson, when we start talking about titrations, you're going to be able to see how a buffer capacity would show in a titration curve in a lesson coming up as well. Okay, so when we're thinking about the Henderson-Hasselbalch equation, again, pH is equal to pKa plus the log of the base over the acid. See, if I keep saying it enough, you guys will get it memorized. And if you think about the most effective buffer, then is where this ratio would be 1 and the pH is equal to the pKa. That's what gives you the most effective buffer so that it can respond to both a large amount of acid or a large amount of hydroxide. So the best buffers are when that ratio of the A minus to HA is equal to 1. So that's also an important point to know. Okay, so here is a multiple choice type question. If a buffer of 4.3 is needed, which acid and its sodium salt will work best? Would it be the chloric acid, the propanoic acid, the benzoic acid, or the hypochlorous acid? And notice that I have the Ka values for each of these acids, in parentheses next to that appropriate acid. So what I'd like for you to do now is to pause the video and to consider which acid would be the best for a buffer of 4.3 when you're putting that weak acid with its sodium salt. So I'm saying pause the video right now and figure it out. Okay, did you pause? Do you have it figured out? What was your reasoning? What were you thinking? What I would do is I would look at taking the pKa of each of these acids. So I would take the pKa of each of these acids and then determine which one is closest to 4.3. So what I would say is that this is the winner, the benzoic acid. And the reason why is that we're going to say that pH is equal to the pKa when this is true. So remember we said the most effective buffer is when these ratios are at 1. So if this is a 1, we know that the log of 1 is 0. So it's in effect you're adding 0. We can say that the pH is equal to the pKa. So if I were to take the inverse log, okay, so inverse log or 10 to the x, okay, whatever, however you want to think about it, but of the pH, so 10 to the negative 4.3, that ends up giving me 5.0 times 10 to the negative 5. And that's what my Ka value would be. So I'm looking for a Ka value that would be close to that 5.0 times 10 to the negative, can you guys tell this is a 5? And looking at that, that's the one that is the closest. So it's the benzoic acid. So the answer is C. C is the closest. All right, I believe that is it for today's lesson. Yep, tomorrow we're going to start talking about pH curves. So good luck, and I hope this helps.